So I decided to build a hollow wooden core surfboard, and I started with a set of purchase plans, PDF plans, because I don't know anything about surfboards. I don't know anything how to build them, and so I wanted to make sure that my design was a proven design. I was able to take those PDF plans and use them to cut out the ribs out of laser, and then the laser cutter was not big enough to actually cut the spline out, so I had to actually draw that out and then cut it by hand. Ended up building my own custom workbench to be able to work on the surfboard. A lot of the laser cutting I would have done with a router, since the laser ended up burning the edges and I had to do a lot of cleanup on the edges. I did some modifications to the board itself. I didn't like some of the designs, and so I spent some time cleaning that up. That's something that could be done later on in the design process. Each board is going to be different for each rider, and so you'd have to have a broad range of plans to be able to adjust that. There's a lot of hand planing that went into it. I think some of that could be cut down with some different processes on machining. I used this super glue because it was with the activator. It worked really well in a clamping method that I devised. See the little pieces of wood, I was able to suck that board up to the concave portion of the frame and hold it in place. Ended up using a lot of polyurethane Gorilla Glue around throughout the whole process of the board. It took a long time for that to set up, or I should say longer, and so there was a lot of clamp and wait, and so I would clamp one side. It didn't seem like I ever had enough clamps to be productive, but you never can have enough clamps. I ended up having to put blocks in certain areas on the board for the fin boxes, for the leash plug, and for the vent. This board being hollow, I needed to be able to breathe, and so the key to it was a Gore-Tex plug, and that allowed the board to breathe. Like in the hot sun, it wouldn't blow up like a bomb. Once I got everything ready, I simply had to seal this board up, and so you had to make sure everything was out of it, clean it up before you put the top deck on. It was like the final time capsule. Used several different methods. I hadn't really struggled pushing this cypress. It was easy to work with, but then sometimes when it decided it was done, it just was done, and I'd have split outs. And it took me 2 or 3 tries to be able to get this top deck on. I used a caul system and some straps and a jig that I created to be able to strap this down and keep it from inducing any twist in it. Then you end up using a lot of hand planing to get this down. This method for steaming I'd seen, and to try to make it to bend the sides didn't work, so I went to my good old tried and true PVC pipe with a steamer to be able to steam the boards that went along the sides of this here. I created this jig to be able to clamp this board, or to hold the surfboard and then clamp the side rails to it. And there was a lot of this portion of the board shaping. It was definitely a lot of skill involved in getting that just the way I wanted it. And so I don't think this is something you could actually do by machine work. The system I used was a West Systems epoxy resin, the 105 system by the Goguen brothers, and I used a 207 special clear hardener. It's designed to really to wet out the fiberglass and also wet out wood fibers as well. And that's one reason why it was so important for this project. Also, the 207 clear hardener allowed us to see the wood after it was done. The temperature got cold about the time I decided to do the epoxy, and really caused a lot of concern. The shop was unheated, so I built a tent to a plastic room, and I took a while. The temperatures were around 56 degrees. I had to bring in a second heater to keep up the temperatures up. Here I'm taking my fin boxes and roughing them up with some 80 grit sandpaper on the edges to provide a little grip for the epoxy. When I set that into the board, I didn't want those pulling out. Ideally, you want the fin to break and the fin box not to break. I found that mixing the epoxy in red solo cups was inexpensive and worked well, and it was easy disposable. Mixed it for about a minute, and then poured it into the fin box holes so that I could then set the fin boxes in place, and it worked real well. I put a little fiberglass in there because I wanted some extra strength. I don't know, decided it was a good idea, and then I had to simply make sure that the fin boxes were square for this board to track correctly. I spent a lot of time making sure that I hadn't induced any twist into the board. Here I am rolling out the 3.7 ounce S2 glass. It's commonly referred to as a 4 ounce S glass. This particular fiberglass has a higher physical property than its E-glass counterpart. S-glass has about 25% stiffer, and it's stronger than E-glass. In fact, it has a higher tensile strength than commercial grade carbon fiber. This particular S-glass is finished with a silane finish and is compatible with epoxy or polyester resins. However, to get the most benefit out of it, it works best with epoxy resins, which I'm using in this particular project with the West Systems epoxy. I'm putting one layer on the bottom of this particular board, and then I'm cutting it to finish. Here I put a logo underneath the fiberglass. I printed it on rice paper, a ripened rice paper, so that it would wet out with the epoxy and disappear, just leaving the ink to be able to see. And I'm using this brush to brush the fiberglass. I want to be real careful not to touch it to alter the weave or anything like that, and give it a visible blemish. And then I'm just simply cutting a relief here so that when I fold it around that edge, it works very well. Here I'm starting to pour out the epoxy resin. Here I'm simply trimming the fiberglass back. Just took a simple razor blade to get that done, and I just trimmed it back and then sanded the edge of it as I got it ready for the top deck. For the top deck, I applied 2 layers of S-glass, gave it about 16/1000ths of an inch thickness of reinforcement, and then I just simply mixed up my epoxy. I used the pumps so that I could mix it a little bit at a time. It was a 1 pump to 1 pump ratio. Simply squeegeed that out and forced that resin into the glass, and then allowed it to wet out. I had to take a lot of care on the edges to make sure that it went well. So on the edges of the board where the epoxy cured, it had a tendency of creating drips, and that was all around the edges of the board. But it wasn't very hard. I just simply sanded that down with some 60 grit. On the fin boxes, I had actually covered just a patch of it with the 2 layers of fiberglass, and so I used a grinding wheel to grind through the fiberglass to the plastic fin box. And once I'd opened that up, I was really happy to see that no epoxy had fallen into it. I did find that when I applied the top coat, I had some air bubbles come out through the form and created a cosmetic defect in the board, and I really found that didn't look good. So I took and I felt that it wasn't a structural issue, and I decided to go ahead and grind out or cut out the little pieces of fiberglass where those air pockets are with a Dremel, just down to the wood surface. Didn't seem like it was going to. There was a lot of wood. You're looking at about 1 inch of wood behind that, so I didn't feel like it was going to structurally affect the board itself. And then I just simply applied more epoxy into those holes to fill them in and give it a cosmetically blemish-free look to the board. And I found it, because I used a squeegee and then also a brush to apply the 2 hot coats to bury the weave of the fiberglass, I had a lot of drips and runs in it, and it created kind of a sanding headache. And so I spent quite a bit of time sanding it down, getting it ready for the final varnish. I used this Epiphanes varnish, and it's considered top of the line. And the biggest thing about it is it has an extra UV filter in it. It's a high gloss finish, and it gives it a really deep luster. There is absolutely a market for these surfboards, but it's not going to be here in Idaho. It's going to be on the West Coast, on the East Coast, or on the Gulf. Retail price on these would be anywhere between $3,000 and $5,000, and it could even be up to $8,000 to $10,000 for a completely custom surfboard. Equipment that would be needed for doing this would be a planer, a bandsaw, table saws, hand tools, sanders, tables, clamps. Starting out, the cost of this could be $3,000 to $5,000 worth of hand tools, keeping it simple and basic. And then as production ramps up, you could purchasing your own tools, and it would be approximately $30,000 to $50,000 to outfit a shop. The biggest thing that could be outsourced would be the routing, the CNC routing of the ribs and splines, and then also planing some of the wood down to 1/4 inch. I'd like to thank my dad for allowing me to plunder his sacred stash of cypress, my wife for putting up with the time I spent on this, to Frank Raymond for use of the planers and the shop equipment, for Josh Lawson's friendship and his help, Jacob Loveland's use of his shop, and for Kyle Kinghorn for believing that I could do this. But most of all, Felium Meum.